Hello everyone, I'm Xunyue, and today I will be presenting my master's thesis titled Sentiment Analysis of Shopee User Reviews Using Machine Learning Models. This study focuses on applying and comparing different machine learning models to automatically classify customer sentiment from Shopee user reviews in Malaysia. And this is category. This presentation will briefly cover the background of the study, the problem statement and research objectives, followed by the dataset, methodology, and the machine learning models used. I will then present the key results, compare model performance, discuss the main findings, and conclude the study. For the abstract, the online customer reviews play a critical role in influencing purchasing decisions on e-commerce platforms. On platforms like Shopee, users generate a very large volume of textual reviews every day. Because of this scale, manual sentiment analysis becomes inefficient and impractical. Therefore, this study applies machine learning techniques to automatically classify the sentiment polarity of Shopee user reviews after pre-processing. A dataset of 2,937 labeled reviews was analyzed. Several machine learning classification models were implemented and compared, and linear support vector classifier achieved the best overall performance among all evaluated model. For the problem statement, the Shopee receives a high volume of user-generated reviews across different products and categories. These reviews contain valuable information about customer satisfaction and user experience. However, manual sentiment analysis is time-consuming and inefficient, especially when dealing with thousands of reviews. In addition, existing studies show that different machine learning models often produce varying performance results on review data. Therefore, the key problem addressed in this study is identifying which machine learning model is most suitable and reliable for sentiment classification on this Shopee review dataset. For research objectives based on this problem, the study aims to achieve five objectives. First, to explore sentiment patterns in Shopee user reviews. Second, to pre-process textual data for sentiment classification. Third, to apply multiple machine learning models to the same dataset. Fourth, to evaluate and compare model performance using standard metrics such as accuracy, precision, recall, and F1 score. Finally, to identify the most effective model for this sentiment classification test. For the dataset description, the dataset used in this study was obtained from Kaggle and is publicly available. It contains 2,937 Shopee user reviews, such as each labeled as either positive or negative, as shown in the pie chart. The dataset is relatively balanced, with approximately 56.8% positive reviews and 43.2% negative review. Before modeling, the text data was cleaned and prepared to ensure consistency and suitability for machine learning analysis. For the methodology, this study adopts a quantitative methodology based on text mining and supervised machine learning. First, the raw review data was loaded and inspected. Text preprocessing was then performed to clean and format the text. Next, TF-IDF was used to transform the textual reviews into numerical feature vectors. The dataset was then spliced into training and testing sets using an 18 and 20 ratio. Finally, multiple machine learning models was trained on the same data and evaluated using identical evaluation metrics to ensure fair comparison. For the machine learning models applied, in this study, six supervised machine learning models were applied. Logistic regression was used to a baseline linear classifier. Linear support vector classifier was applied due to its suitability for high-dimensional text data. Random forest was included as an ensemble-based method, while multinomial naive Bayes was used as a probabilistic text classifier. The same tree and key nearest neighbors were also included, mainly for comparison purposes. All models were trained using the same TF-IDF features to ensure consistency. Then, for the model performance, this slide shows an example of model performance using logistic regression, and logistic regression demonstrates strong baseline performance, achieving an accuracy of approximately 0.90. Precision and recall values are relatively well-balanced, indicating consistent performance across both sentiment classes. These results suggest that logistic regression is suitable as an initial sentiment classification model, but further comparison with other models is necessary. And then, for the overall model comparison, this slide compares the F1 score of all evaluated models among all classifiers. Linear's SVC achieved the highest F1 score, indicating the best balance between precision and recall. Although random forest and logistic regression also performed well, their overall F1 scores were slightly lower than linear SVC. Therefore, based on this comparison, linear SVC was selected as the best performing model in this study. And then, for the discussion of findings, looking at the full performance comparison, linear SVC achieved consistently high scores across all evaluation metrics, including accuracy, precision, recall, and F1 score. Compared to other models, linear SVC maintained a better balance between precision and recall, which is important for sentiment monitoring tasks. Although random forest and multinomial naive Bayes perform well in certain metrics, their overall F1 scores were still lower than linear SVC. This suggests that linear models are particularly suitable for high-dimensional and sparse text data such as TF-IDF representations. Finally, for the conclusion, this study demonstrates that machine learning models can effectively classify sentiment in Shopee user reviews among all evaluated models. Linear support vector classifiers achieved the best overall performance based on F1 score. The findings highlight the suitability of linear models for sentiment analysis of high-dimensional textual data. However, the dataset is limited to a single e-commerce platform and language. Further studies may explore large datasets and more advanced deep learning approaches to further improve performance. Thank you.